I got to thinking that you guys are probably sitting at home, bored to tears. You've had all this time off, you've not done any math, and you're just getting really lonesome. So I wanted to go ahead and get our video completed for 1.9, where we talk about measures of variation. Um, the previous set of notes that we looked at, we referred to the measures of center. So we talked about the mean, the median, and the mode. And that kind of gave us an idea of where the center of all the values for our data sets happen to be. The measures of variation, we build up through this to get to our standard deviation, which kind of measures the spread of the data that we're looking at. Um, I have worked on your guys' notes for this first unit all this time that we've been off, and I actually finally have the first unit completed, and I'm getting ready to get started on the second. I just hate that I have to do all this again, since I already had the calculus notes done, but that's neither here nor there. It doesn't matter. I don't mind doing this as long as it helps you guys out. So anyway, the measures of variation, unlike the measures of center, we're looking at the spread on the set of data that we're given. So we have, you notice right here, two teams. We have team 1 and team 2. These are the 5 starting basketball players on these respective teams. And what you can't really tell much just at first glance, because the data has not been compiled for it. It's just being presented. But what I do want to note is that they both have the same mean height of 75 inches. They both have the same median height of 76 inches. And they have the same mode of 76 inches. So as far as the measures of center go, these two sets of data are very similar, they're, if not identical. But what I do want you to pay attention to is the shortest player on team 1 compared to the tallest player on team 1. And then do the same thing for team 2. The shortest player is 67 inches, the tallest is 84 inches. So there's a larger spread in the range of the data on team 2 than there happens to be with team 1. So we're going to kind of analyze this. We're going to use these two teams for the first few examples, actually for all the examples in this set of notes. Truth be told, I made a video for these notes. I was going to do half the notes and then do the next half and make it 2 videos and break it up. First video was 15 minutes long, and I realized I only had one more example to do. So here I am redoing all this because apparently I have nothing better to do with my time. The range is the first thing that we want to talk about, and with the range, you're just simply taking the maximum value of the set minus the minimum value, and that gives you the range of the data. And that's what we looked at just a second ago when I circled the values on team 1 and team 2. But you can see right here the team 1 range is 6 inches, the team 2 range is 17 inches. So there's greater variation in the data sets for the 2 basketball teams, despite their measures of center being exactly the same. So what we want to look at now is the sample standard deviation, which is just the standard deviation of the sample set that we happen to be looking at. And we're going to do this kind of a process through the first 4 examples, where we build up to, we take all the different components of the standard deviation. Because initially I do want you guys to work on some of these by hand using the calculator. When we meet in class again, I'll show you how to do these really quickly on the computer using Google Sheets. If you want me to show you on Desmos, I'll do that as well. But there's a lot of different ways you can do this. But understanding how the formulas work and how the values are found is very important to understanding what they mean. Finding them by the computer is great, but you still need to have that inherent understanding of what it is that you're looking at. So the first thing we're going to look at is how far each data point for team 1 varies from the mean, and that is our first step in finding the sample standard deviation. So what that means essentially for example 1 is we're taking each data point, which we represent by x sub I, minus x bar, which if you recall from our previous set of notes, that's the sample mean. So in this case, our sample mean is 75 inches. We highlighted that at the beginning here. We have a mean height of 75 inches. So for example 1, all we're asked to do is find the deviations from the mean. So we're going to take each data point individually and subtract the mean from that point. Second height was 73 inches. And our last one is 78. Pretty short basketball team. Anyway, and that's all you have to do to find the deviations from the mean. You just take every data point, subtract the mean value of that set, and you have all the deviations from the mean. And if you've done this correctly, when you add these values together, they should sum to 0. So -3, -2 is -5. -5 plus 1 is -4. -4 plus 1 is -3. -3 plus 3 is 0. So we did find the correct deviations from the mean for this entire set of data, which means we also have the accurate mean for this set. And that's going to take us on into our next component of the standard deviation, which is the sample variance. Or actually, it's the sum of the square of the deviations. I'm sorry, I jumped ahead of myself. The sum of the square of the deviations. So if I just list our deviations again that we just computed, we had -3, -2, 1, 1, and 3. What we're going to do is apply this equation right here. We have the sum of x sub I minus x bar. That's what we just computed at the beginning in example 1. And then we just square those values, and the sigma notation just means we sum all of that together. So with a small set, it's really easy to do by hand. So we're going to go ahead and take all these 5 values of the deviation from the mean, and we're going to square each one of them. So we have 9 plus 4 plus 1 plus 1 plus 9, which is going to be equal to 24. Okay, we just squared our deviations from the mean and added them together, and we get 24. So that is the sum of the squared deviations for team 1. This leads us into our next part of the sample standard deviation, where we compute the sample variance, which is denoted by s squared. And if you look at the notation here, the numerator is the sum of the squared deviations, which we just found to be 24. And the denominator is just our sample size minus 1. Okay, so that gives us our sample variance. And then the next step, which will take us right into the standard deviation, is really pretty simple from here. So we take to find s squared for the teams on player 1. We already have, I'll put in the notation here. We've computed the numerator already to be 24. Our denominator is the sample size, which is 5, minus 1. And we're going to end up with 24 over 4. So we get in this case, because s is squared, our solution should also be in square units. We get 6 square inches as the sample variance for the heights of the players on team 1. That really doesn't mean a whole lot to us as far as what is the standard deviation, how spread out is this data. But our next step is going to make more sense. So what we have, I need to clarify this on our notes, that should be s, not n. We take basically what we found in example 3, take the square root of both sides, and that's going to give us our standard deviation, because if you look here underneath the radical, that is the sum of the squared deviations. And in the denominator, we have the sample size minus 1. Which what's underneath the radical is exactly what we found or computed in example 3. So what's left is to take the square root of both sides and we're going to solve it, and we're going to get what is going to be S. Later on, we're going to see sigma, which is the population standard deviation, but right now we're just looking at S, which is the sample standard deviation. So all we have to do then to find S, remember we had S squared was equal to 6, so S is equal to, gotta make sure I put my units on there, S is going to be equal to the square root of 6. So I have my calculator pulled up. Let's compute the square root of 6. We get 2.45 inches. So we'll go back and put this on here. So the standard deviation for the heights of the players on team 1 is 2.45 inches. In example 5, we're going to do the whole process from beginning to end, and I'll show you how to do it with a table, and it might make more sense if we put it all together. That was just kind of a step-by-step introduction to how to compute a standard deviation. With example 5, we're going to do the same thing we just did with examples 1 through 4, but now we're going to use team 2 as our data set. And just recall from the beginning of our notes that X bar, or our mean, is 75 inches. We need to know that before we can continue with this problem. So in this example 5, we're going to compute the standard deviation for team 2. One of the things that my stats professor taught me a long time ago is if I make a table, things become a lot easier, and I'm going to show you how she showed me to do this as well. So in the first column, I'm going to have my X sub I, which is my data points. So I have 67, 72, 76, 76, and 84. Is that all of them? Yeah, that's my 5 players on team 2. So then my second column is just going to be X sub I minus X bar. So it's going to be these data points in column 1 minus my mean, which is 75. So it's 67 minus 75, 72 minus 75, 76 minus 75, and then 84 minus 75. Column 3, I take those same values from the second column and I square them now. All those answers, I square those. And then just to double check everything, I'm going to take the sum of that third column. So 64 plus 9 is 73, 74, 75. I get 156. So the sum of the squares is 156. Now from here, I can compute the S squared value for the sample variance, which is going to be 156 over sample size minus 1. So I get 156 over 4, which is going to be 39. So my sample variance is 39 square inches. If you heard a little dinging sound, that was my wife's picture of Jimmy rattling. Sorry. So 39 square inches, but our heights, like we said initially, they're all in inches. We don't have square inches of a basketball player, so we have to come up with that standard deviation. So we just simply take the S squared equals 39, take the square root of both sides, and again we go back to the calculator and we do square root of 39 is going to be 6.25. So the standard deviation for team 2 is 6.25. Standard deviation for team 1 was 2.45 inches. So there's more variation with team 2 than there is with team 1. We did see that with the range as well. But the closer that standard deviation value is to 0, the less spread out the data is. We're going to look at, here in a little bit, we're going to compute standard deviation another way, which sometimes is easier to do by hand than the way that I've just shown you. Just depends on the size of your data set, but both equations will give you the same answer. Let's see. So the computing formula, what we've looked at is the defining formula for the standard deviation. The next thing that we're going to look at is what's called the computing formula for the standard deviation. And that is given by this equation right here in the middle of your screen. And the first notation right here, this sum of x sub I squared, is we're taking all of our data points and squaring them and then adding them together. So it's the sum of all of our data points squared, or the squares of all of our data points rather, minus, again, same notation, we take the sum, in this case we take the sum of everything first, it's the sum of all the data points, then we square that solution and we divide it by our sample size, and then that's going to be over the sample size minus 1. We take the square root and we'll have our solution. We're going to apply that in example 6. So let me write down the heights of the players for team 2, 67, 72. Okay, so we have 67, 72, 76, 76, and 84. So there's the heights of our players, and we're going to use the computing formula, which is the sum of all of our data points squared minus all right, so here we go. For the first part of this, we're going to take all of our data points, so it's 67 squared plus 72 squared plus 76 squared plus 76 squared plus 84 squared. And we're going to punch that in the calculator. I'm just not that good. So 67 squared plus 72 squared plus 76 squared and we get 28,281. Okay, so that is this first little box right here. The second box that I'm going to do is the sum of all the points, and then I square that. So it's going to be the sum of x sub I, and then I square that sum. So let's go back to our calculator, and in this case we have 67 plus 72 plus 76, and I'm going to square that answer, and I get 140,625. But the next step then is to divide that by n, which is our sample size. So it's going to be this sum divided by 5. So I'm going to take that solution, divide it by 5. And now I have 28,125. All right, and then the last part of it is the n minus 1, which is going to be 5 minus 1, which is equal to 4. So if I put all this together, the first thing that we found was the 28,281 minus the 28,125 divided by 4. We're going to take the square root of that. So let's go back to the calculator again. I get 28,281 minus 28,125 all over 4, and I get 39, and then I take the square root of that, and what do you know, it's the exact same answer that we found before. So we get 6.25 inches as our standard deviation for team 2. Use whichever method you prefer. I think in the homework I may give you some directions on you can use whichever one you want to use, and some of them I tell you to use the computing formula. So the computing formula is what we saw here in example 6, but you can use whatever method you prefer. Again, like I said, I'll also show you how to do these on the computer when we meet together on Monday. Please read the rounding rule here when you're using the calculator. Don't round any solutions until you get completely finished with the problem. Further interpretation of the standard deviation. So I've taken these two data sets. I've computed the sample mean and the standard deviation for both sets already, just to kind of show you visually how these things look. So for data set 1, which is there at the top of the screen, the mean is 50 and the standard deviation is 7.4. For sample or data set 2, the mean is 50, the standard deviation is 14.2, whatever the units might be in this case. But graphically representing these, what you see in the middle of each one of these data sets is the mean. And then to the right of each one, this is one standard deviation. Then we have 2 standard deviations. And then we have 3 standard deviations. And then we have the same going in the negative direction. So that's what the standard deviation looks at, is the spread of this data. Now typically, almost every time, at least 99% of your data is going to fall within 3 standard deviations of the mean. If it doesn't, if you go beyond 3 standard deviations, then you have a large spread, possibly some outliers that we're going to address that later on as well. But you can see from data set 1 here at the top, the data is tightly clustered around the mean. There's not a large spread with data set 1. With data set 2, we have some points that find their way. One is between 2 and 3 standard deviations away from the mean to the left. We have another point that is between 1 and 2 standard deviations to the right. We didn't have that same kind of spread with data set 1. 3 standard deviation rule, I just mentioned that. Almost all observations will lie within 3 standard deviations of the mean. And that is the conclusion of the measures of variation. Again, this is a pretty straightforward set of notes, just computation heavy. Please learn how to use these formulas. Please understand what these formulas mean. We're going to start tying more of this together, and everything's going to make sense. So again, I hope you guys have a great night. Kind of miss seeing you guys this week, but hopefully I'll see you on Monday. Everybody take care.